Good afternoon again. We are going to start our afternoon breakout session. For those of you that are in the hallways, please make your way into Hall A here. This afternoon's breakout that you're going to be attending will feature updates on cement and supplementary materials. With us today, we have an esteemed panel of industry experts. Esteemed, yes. Who will discuss material futures, product demands, product production, and more. On our panel today, we have Michelle Wilson from the Portland Cement Association, who will talk about the cement industry's move to Portland limestone cements, followed by Doug Rhodes of Boral Resources, who will talk about the future of fly ash. After Doug, Joe Clendenen of Wholesome will talk about slag and its availability in the market. And finally, TJ Murphy from Materials and Research will talk about how DOT researches and approves materials for NDDOT projects. Each one of our panelists will have about 10 minutes to give their overview. At the end, we're hoping that there is some time left over so that we can field some questions from the audience. So with that, please help me welcome our first panelist, Michelle Wilson from the Portland Cement Association.
Thank you, Art. Good afternoon, everyone. I'm here to talk about Portland limestone cements. By a show of hands, who knows what these are? All right, that's not bad. That's like 25% of you. We have known about this product for many years. It's been well versed in Europe and in Canada, and actually has been in the United States and approved for use since 2004 and moved to higher amounts since 2008 and 11. The reason we're doing this is not to surprise anyone, but for sustainability. And just last year, PCA and its members put out a roadmap to carbon neutrality. The goal is to be carbon neutral by 2050, and the ways to get there include blended cements. So there's many other things that need to be optimized in a concrete mixture and in concrete use and construction. But the choices we make with the blends of cement will improve its sustainability footprint. So what is a Portland limestone cement? Well, it's exactly what it sounds like. If you know what Portland cement is, its main characteristics are the clinker that is ground to a fine blend and interblended with gypsum or calcium sulfate to control the heat of hydration. And that's your everyday good old fashioned Portland cement since the early 1900s, late 1800s. However, since the 80s and 70s in Europe, people have been blending other products, and many types of products are called supplementary cementing materials that you hear about today. But we've also been intergrinding limestone as an addition to the cement. What's important here is thinking about it as an optimized material at a cement plant. So instead of this being added subjectively at a ready mix plant, this is added by the cement producers and measured and performance tested before it goes out to market. And currently this is probably going to save you about 10% on your CO2 footprint. The other takeaway with the US standards is that there are 1157 cements that are performance-based, that they basically tell you are general use, moderate sulfate, low heat, high early, et cetera, that have been in practice and had limestone cements since early 2000s and have been used in pavements successfully in states like Colorado and others, and have lots of great case studies in the United States as well as all over the world. Now, we've moved with our specifications to the blended cement arena for higher amounts only because that seemed like a safe home for people who are unaware of a product. So it's not that much different than Portland cement that has up to 5% limestone interblend in it. It's just a higher amount, and we've allowed since 2011 2012 officially, type 1L cement, and then type 1T cement usually has another SCM in it to meet moderate sulfate or moderate heat, et cetera. So where are these allowed? everywhere. 44 states have embraced and accepted PLC cement. So that includes North Dakota, if you can figure out where you are on the map. And the ones that are holding out, it's purely due to wanting their own research numbers. So we're working on those states, and we should have all 50 states, most likely, if not by the end of this year, within the next couple of years, because this is a product that is here to stay. It's not meant to be forced on you. It's been out for a long time. And type 1L cements, their properties are the same, if not slightly better than an ordinary Portland cement. And that's just due to the processing of it after the clinker is made. They're typically ground slightly finer, so that gives us some early strength generation. And it also may or may not speed up your set time. So the things that you're thinking in your head for performance are actually the opposite of what typically happens out there in practice. And if you do need to fine tune your mixtures, it might just take a slightly different water demand, a slightly different admixture dosage, but it's not night and day from ordinary Portland cement mixtures. And this has been proven by many different types of concrete mixtures over the years within the United States as well as in other countries. We have lots of research available at PCA to prove that to you. What this is going to do for us is really contribute to lowering the carbon footprint of concrete. And that's really what our end goal is here. And the replacement level is not like using an SCM. It weighs, it's the same 3.15 specific gravity. We're looking at very similar mixed designs with a 1-to-1 replacement ratio. So this typically allows for the same values of fly ash and values of slag that we commonly use. So that's something to consider. All right, so if you're asking about the performance of concrete, what you want to look at here is how it may affect your fresh concrete properties. And so this is where contractors care. What's it doing to my slump? What's it do to bleed rate? What's it doing to set time? That's the kind of performance measures that engineers don't normally think about in their specs. The good news is overall, it's comparable to ordinary Portland cement. It may decrease your slump if it's ground much finer than your typical blanes that you've seen in your regions. It may decrease your bleed, again, based on fineness, and it may speed up your set time, but it rarely delays your set time. So that's something to consider. And then depending on the fineness and the optimized blend, this could increase the hydration rate, and it may actually increase early age strengths, and depending on your curing, control your long-term rates. And the good news on the durability side is we have a lot of information on long-term performance of these cement types, and we know they're durable. If you're dealing with anything on sulfate resistance and knew about the studies that were performed in Canada about 5 years ago, those were questions based on some frost susceptible aggregates in a belt line in Texas, of all places. And so they were worried about the methylene blue test and those limestones failing it. And they did some sulfate tests on these types of cements and found that everything we were worried about, we were wrong. And it is still proven to have sulfate resistant, which is a very harsh test for those who have performed that. So these materials do work well in concrete. And we have a lot of proof of that. And if you have not gotten familiar with them, just know that you can get them in any flavor you want. So if needed in a 595 blend, they can be high early, they can be moderate heat, they can be high sulfate. It depends on what your market demand is as to what cements would be available for you. And when it comes to mixtures, especially for paving, the things to look at would be what type of bleed rate and set times that you might get. And again, it's not, the perception is often that it's going to be a delayed set. And what you might get is a quicker set based on a 1-to-1, but it again depends on the blade. Okay, so there are reports and lots of research available to you. I don't have time today to get in great detail of that, but I want you to be aware of these resources. So there's a serial number report here. These slides will be shared with you after this presentation. And I've added on some additional slides for the nerds in the room with lots of data, as well as I want to make sure that you have any data that you need. If you want information on abrasion resistance, if you want information on freeze thaw or scale resistance, I have that available for you. And I'll appreciate your time, and I'm going to turn it over to Doug, who's going to talk about fly ash from Boral. Thank you.
Good afternoon. Here we go. One quick part of the intro. I was introduced as Doug Rhodes with Boral Resources. This February, Eco Material Technologies has purchased Boral Resources, or Fly Ash North America operations. So you can see the new logo at the top of the slides, and I'll probably get a new polo out of the deal, but we'll be known as Eco Material Technologies now. I'm going to show of hands, anybody doing business with Boral here? Ready mix producers? Yeah. So you'll start to see that in the near future. Just for reference, we're in about 45 states in America. Roughly 6.5 million tons sold last year. So that gives you an idea of the footprint. And you can kind of see the distribution locations and the ash management locations on the map there. Today, I wanted to just kind of give you an overview. We only have 10 minutes, so we can't get too far in the weeds on ash beneficiation and utilization. But I can give you an idea of what Eco Material Technologies is doing regionally here in the North Dakota area and nationally to either maintain or augment supply of SEMs and fly ash. So where's all the ash at? Regional disparities. A lot of times you're going to find that we have a lot of ash someplace and we don't need it there, and we have a place where it doesn't have any ash. So a lot of our logistics is by rail. We rail materials from as far as Illinois all the way out to LA, and from Alabama up into the Northeast. Here in North Dakota, especially, you can produce concrete and place concrete in the winter, but it gets a little difficult and business has a lull. So one of the things we're doing is we're storing materials in flat storage and in vertical silos. The other thing we do is beneficiation. I'll show you a couple different technologies we use for carbon mitigation. But also we blend materials in the Southeast. We blend an F and a C, and it gives properties with the F and the C that are real desirable to the concrete producer, namely set time and ASR durability, sulfate soundness, etc. And then quality disparity. We'll use a proprietary chemical treatment on the ash to render the carbon inert. And I've got a slide that kind of dives into that a little deeper. The other thing you're going to start to hear a lot of buzz about, and if you already haven't, is reclaiming or harvesting landfills and ponds that have storage of ash from yesteryear in them. We're active in the Northeast on that right now. If you look at it, it comes into two categories. I'm kind of going back and forth with the glasses. On a lower LOI, where you have a lower carbon content, a lot of times you can just take that material out of the ground, dry it, screen it, and put it in a silo, and it meets 618 requirements. There are some occasions where you'll have a much higher LOI in that impoundment, and it's going to require some sort of beneficiation like a CBO or a carbon burnout, which will reduce that carbon content to an ASTM acceptable level. And I'll also kind of give you a brief overview. One of the emerging technologies is ground bottom ash. They're close to getting that approved in ASTM in 618 or in a designation on its own. 618 may go to just coal ash, not coal fly ash. It's kind of where it's headed right now. Then also you got to look at imports. There are materials coming in from outside the US, Japan, Turkey. You'll see some of these if you're in coastal areas mainly. And then natural pozzolans. I'll use the acronym EMT. I'm trying to get through this without saying Boral. You'll get EMT is now operating. It's in its final shakedown. Should be operational by the end of this month. The Kirkland Natural Pozzolan mine in Arizona, and I have a slide on it. And the only reason I bring up those technologies is because they may make their way to this regional area at some point in time. So I kind of talked about this regional area and the ability for us to move materials around in lull season or winter, and we use vertical storage. You know, one of the big things that happened here this year was Coal Creek was slated to be closed. It was purchased by Rainbow Energy and will remain operational for the foreseeable future. So as far as a Class A good pozzolan that's very consistent, we're lucky in this area to have that one. They've just recently renovated the dome there, and we can load out up to 100 trucks a day there, and in combination with rail. Again, we have that strategy for the winter time or the low months to store material and have that available in the peak season. I'll address harvesting. This slide here and the next slide is from a project we have in Pennsylvania where we're excavating the material, drying it and sieving it, and it meets the 618 criteria. A lot goes into looking at an impoundment, and I'll back into it and say there's two types of impoundments. One is a dry stack. That's where they've conditioned the ash, they go up and compact it in place. The other is a pond. The pond is not as friendly to excavate or reclaim. There's stratifications of density of materials and layers that are created by water flow. So the hydrology of that is not as friendly to go out and reclaim or harvest as a dry stack. This is a dry stack in south central Pennsylvania, a little over 2 million tons. We've been working on this since 2016. We started testing 2018. I think it went online. There's kind of a site photograph of the impoundment. The big, pretty green stack in the background is the ash stack. And then on the left-hand side, you can see we use a trommel up front to remove larger agglomerations. It goes through a drying, then the bag house is there, and there's a vertical conveyor belt that takes it up into the silo after it's been sieved. And that particular, we get good fineness on that by just sieving it on a number 20. One of the things that we'll probably see, we're starting operation in Texas. It's broke ground at Oak Grove. Fly ash and bottom ash. Fly ash is carried out the flue gas or the exhaust, and then the bottom ash falls from the bottom of the boiler. And just nudge me, I'm getting close on time, right? Okay. They roughly have the same chemistry. So you can take these materials and grind the bottom ash to a fly ash consistency and use it just like you would a fly ash. Now there's a couple little things that go on. You're gonna have an angular, not a spherical nature. So the water demand is slightly higher, but the chemistry is identical, and the strength activity index is almost identical. Again, we've got this operation northwest of Phoenix. It's going to be operational at the end of this month, roughly 200 tons an hour capability. And there's the deposit, they say roughly 38 to 40 million tons of material readily accessible. So this material will be pushed into the Western market. But logistics, who's to say it couldn't make it this far by rail? I wanted to kind of drop back that southeastern blending that we did. We did a great deal of work with the Georgia, Alabama, and Mississippi DOT. Got all this certified years ago for use as a pozzolan in their area. It does meet all the 618 requirements on both sides. Both the feedstocks for the F and the C are spec material, and then we produce what's called a performance pozzolan. I'm going to run out of time, but one of the things I had mentioned earlier was the chemical pacification of the carbon content. And you can kind of see the bottom right chart shows you in a polynomial curve. As you add this chemical to the ash in pounds per ton, it brings that foam index number. And the foam index number is just generated by a mixture of ash, water, and you add AEA until you get a stable foam for an extended period of time. And this is what's good for those lower LOIs if you still have activity. We purchased the rights to PMI's technology, which is a carbon burnout technology. They were operating about 4 plants in the northeastern United States in the past. Around 70 million tons were processed through those plants and produced a real desirable material as far as air and training. So just to kind of summarize ash and ash utilization in your area, for the North Dakota area, you're pretty much looking at Coal Creek, augmenting those supplies, making sure that you have the storage that's required to have that material stored on the off-peak seasons. And you may start to see some harvesting in this area. And that harvested ash will come in the form of an F. It'll probably be just dried, sieved, and put into the marketplace. But the other side of things, you may begin to see SEMs or other materials, and you'll start to see some emerging technologies like ground glass and some things of that nature. They're starting to make headway into the marketplace. So with that, I'll close and hand it over to Joe.
Can you guys hear me okay if I leave it down there? I have this problem all the time. You can see me okay, right? Why are you laughing? No, it is an absolute pleasure to be here. My name is Joe Clendenen. I am with a company that this month is called Lafarge or Lafarge Wholesome. In about 31 days, we are going to change our name completely and just be called Wholesome. Now, this is about the 4th iteration that I've had working for the company. I just want to make sure you're keeping up to speed. We will have a quiz at the end. That being said, I'm here to talk about slag cement. It is an absolute pleasure, as I said, to be here, to be in person. I feel a lot of excitement coming from the crowd at every one of these I go to now. I'm sick of looking at monitors, I'm sure, as much as you are. So I've entitled this the briefest overview of slag cement you will ever experience. I cannot go into the depths of everything that you should know about the product in 10 minutes. The good thing is, even though the title of this round table discussion is the future of products or new products coming out, slag is really not a new product, it's just new to you. So we're going to talk about that a little bit. Now, the interesting thing about what Doug said, what Michelle said, and what TJ is going to say is that all of these new products that we're talking about today, for the most part, they're already allowed. All you simply need to do is adopt the most recent standard of ACI, ASTM. There's lots of information about these products coming out that are indeed just new to you. There's a lot of good information. If you look at the red, look at all those products that are already allowed in ACI 301 and 318. So it's going to happen organically. These quote unquote new products are coming out, which again would be allowed for use if you simply updated your specification. Follow me so far? I don't want to go too fast on you. So slag cement, I said it's not a new product. In fact, it predates use before Portland cement. It is older than Portland cement. There is a huge track history, lots of information that's out there. I'm going to give you a couple of websites, okay? But it's new to you. And it's new to you because slag cement comes from iron ore processing. So where the iron ore is, where it's being processed, guess what? That's where slag cement has historically been. But with availability of product and shipments and demand, it is now available and has been for a couple of years now in North Dakota on, I would say, Missouri River and east, okay? So if you want slag cement, very simply, my ask at the end, foreshadowing, spoiler alert, is simply allowance and communication. If you forecast, you will have some available, okay? That being said, everything I want you to know about slag cement, number one, it meets an ASTM. That ASTM is C989. Everybody say it with me. 989. Get that in your track record. That's going to be my ask for today. Okay. The second thing I want you to know, it's already North Dakota DOT approved. We've already done the legwork. It's available for you. Slag cement, very simply put, is another type of supplementary cementitious material. Undergoes the pozzolanic reaction. If you're looking for enhanced durability aspects, enhanced strength, enhanced ASR, sulfate resistance, there are methods, there are ways of using slag cement to get that type of performance. Again, I'm not going to jump into too many details today, but just understand we have lots and lots of information for you to use the product. That being said, my ask is simply this. I don't hard spec products. My ask is to include an OR statement in your specifications. What's the word? What's the number that I want you to remember? 989. I can't hear a word you're saying. It's all in my head, right? Most of the time. That's great. You could be laughing, crying. I don't even know. But these are the two websites I want you to use. There is again, a plethora of information. The first, Shameless Marketing, that's my website. I put on there wholesome because I'm supposed to do that. That's what the logo police told me I'm supposed to do now. The second one is the Slag Cement Association, very similar to the Portland Cement Association. Lots of good information, case studies, information on everything I told you about the durability aspects, acceptance, all that kind of good stuff. So that being said, I mentioned before, all of these new products that we were talking about today, the vast majority of them, they're already allowed in the industry-wide specifications. You simply need to update yours to the current version of 301, 318. New products will be coming. The interest in sustainability, the interest in enhanced durability of concrete is only going to grow, and all of these products fit in. I forgot to mention the third thing about slag cement. It's a recycled product. So if you're worried, if you're losing sleep at night in North Dakota regarding the CO2 intensity of your products, it fits right in. Incidentally, if you don't care about that, I'm from the Midwest myself. It's easy to laugh about those type of things, but what I want you to do is I want you to go back after we're done with this tonight and look up the latest executive order on the $1.2 trillion infrastructure bill and look up the word buy clean and see what's potentially coming out. If you're not interested in global warming potential or CO2 intensity, you will be very shortly. That being said, if you want to send me hate mail, no, here's my information. I really appreciate it, guys. I want to get to the questions. I want to hear what you have to say. Always a pleasure being in North Dakota. I'm going to turn it over to TJ from North Dakota DOT. He's going to talk about specification allowances. Thank you very much.
Afternoon, everybody. I'm going to give a little brief update of why we as owners want SCMs in our concrete. Well, we're all looking for long-lasting, durable, and economical pavements, and I think SCMs play a part in that. There's some summaries here about SCMs in an effort to allow more time for questions. I'm not going to really dive into a lot of these because they've been covered throughout the day, and if you're a producer, I would encourage you through your mix design processes to find out how all these tools work with your mixes. Why do we want to use SCMs? Sustainability is also another reason. Roughly 70 million tons of fly ash are produced every year. Of those tons, about 22 million are used, and 60% of that is used in concrete, cements, and then the other constituents kind of rotate around other construction activities like flowable fill, structural fills, or FDRs. Some local testing that we've done and some spec updates that I'll go over next involve Class C fly ash, which in the past hasn't been allowed in our industry or in our state, and now it will be moving forward. Some of the findings here you can see from the graphs compared to a Class F fly ash, we've seen increased 7-day strengths. We've also seen an increase in admixture demand. So if you're a producer, factor that into your mix design. Also seen some increased durability in comparison to 100% or non-SCM utilized mix, which leads to maybe possibly some ASR or sulfate mitigation. In all, it makes the concrete a little bit less impermeable than your standard OPC mix. The updates in the spec, I'm not going to drill down in all of these and just kind of show you some of these slides and walk through them quickly. Concrete used in bridge beams and box culverts will remain the same as it always has been. You can use class F fly ashes at a 29% replacement by weight. ASE concrete will also remain the same with the exception of allowing class C and slag cements. Other cements have been up from 29% to 35% and will allow class C, class F and slag cements. Some of the requirements for these products are outlined in the spec. There'll be a link for the spec later. I would ask you to go out and read them yourselves in your free time. Again, some more chemistry requirements. I won't read through all of these. Basically, any fly ashes will be governed by AASHTO M295, and the slags will be governed by AASHTO M302 and be required to be grade 100 or 120. Already kind of walked through a lot of this. Bridges will stay the same, class F fly ash, 29% replacement. Other PC applications have been up to 35% replacement. And class C fly ash will be allowed. And the governing AASHTO provisions are listed there, along with a link for the specification that I would encourage you all to go out and look at. And that's all I have. Thank you for your time.
All right, so that's a brief overview from 4 different panelists. We have about 15 minutes or so that we want to turn this over to you. We realize that it's later in the day and we had lunch and snacks and we've been here a while, so we want to make this a little bit interactive. So at this time, do we have any questions from members of the audience? Don't all speak at once. Okay. I'll repeat the question and then each one of the panelists has a microphone in front of them, so.
This question is probably more for TJ, I guess. With going to 35% fly ash, your typical specification is 3,000 PSI at 7 days. Has there been any consideration as to altering the specified strengths to allow for that higher percentage of fly ash? Or the ultimate strength is going to be much higher past 28 days?
Are these on? They are on. Currently, the 3,000 PSI at 7 days will remain in place. As our primary mix designer, do you see a concern with that, Greg?
When we get up to that 35% fly ash, we might struggle getting that 3,000 PSI at 7 days in some cases.
Well, I guess that is an opening strength requirement, so we could possibly investigate that moving forward with the specifications.
Yeah, but I think even in the mixed design process, we're required 7,000 or 3,000 at 7 days. So, you know, if we take some of these mixes that we have had success with, run them again at 35% fly ash, we might not make that 3,000. And does that necessarily make that mix bad? I don't think so.
I wouldn't think so either. No, that's a thing that we can have discussions in the future, work with contractors as that comes out.
Okay.
Ultimately, I think you've heard before that strength is less of a criteria for long-term performance and durability. So whether we hang our hat on that 7 day, 3,000 PSI and how much that really is mattering to the end product we get, I guess, would be something along the lines why a 3-inch slump needs to be a 3-inch slump or less, I guess. It's something that we can work with you guys in the future.
Other questions? Don't be shy out there. So while you're thinking them, let me ask Doug here. You talked a little bit about the harvesting in other parts of the country. You said a little bit here, you know, could be something that comes about in North Dakota. When do you think that is, you know, might happen? And what are you seeing as far as any changes in mix designs or things like that when you use harvested ash versus, you know, newly produced ash at these facilities?
So as far as the North Dakota area, We've done some investigation at Coal Creek into their fill with two new entities, Rainbow Energy and Eco Material Technologies. I'm not sure where that'll go. It has been looked at. And as far as performance, when you look at Class F in particular, it's a one-to-one replacement, and performance is almost identical. You will see one of the odd things that came out of the harvested ash is that the carbon content of the harvested ash is actually rendered a little more inert. It's not as reactive as far as trying to grab that AEA out of the concrete mixture. So it ages well. But on a performance basis, we've seen it on one-to-one. Sulfate soundness, ASR mitigation, all the properties that you want fly ash utilized for are essentially the same with the impounded ash.
Anything else out in the field here? If not, maybe we'll go over to Joe and Michelle. One of the things that when I'm talking to the DOT or to counties or city governments, and they're looking at specifying concrete pavements and concrete roadways, when we're dealing with the increase in funding that we have, the first question that comes up, either one or two, is do you have enough employees to do all the work? And then two, what does the supply chain look like? We're seeing supply chain issues throughout the country and throughout the globe on certain commodities. What are we looking at as far as like slag supply and being able to bring that in the market? And Michelle, if you maybe want to touch on a little bit on PLCs and that supply, just give us a good feel of what we're looking at coming into this construction season.
Yeah, how much can I put you down for?
Well,
it's the same thing. I mean, whether, and we do PLC as well. We also do fly ash, though not in North Dakota. It's forecast early, forecast often. If it's available, slag cement is available, Portland limestone cement, it's already used. In fact, I would say for us, it's the main cement already in North Dakota, has been for the past few years. So yeah, I mean, it's good to be in the concrete business, right? Things are progressing, things are growing. Infrastructure bill we see is going to grow even more. So accurate forecasting, we're bringing in more imports across the country to supplement. So things are very good. But again, it all gets back to look ahead, look at what you need and plan it out longer today than you did certainly back in 2009. So it's good to be in the concrete industry.
And I would just add to what Joe said that for PLCs, the demand originally was low when it was only in the performance space specification of 1157. People are afraid of not knowing what's in their blend. So that's not a very popular specification, but 595 and 150 cements are extremely popular, and there are members that are moving to PLCs where they were picking up a lot of demand. They're now turning to 100% in the market. And so you're going to see this product, you will be working with it, and there is technical data to back it to help you with your mix designs, but it shouldn't be anything that makes you feel any pressure. It should make you feel excited to help with your sustainable footprint.
Perfect. Doug, do you want to just comment a little bit on your position on fly ash for the North Dakota market here in the upcoming construction season?
Well, the one thing that was real positive that occurred in the last year was the acquisition of Coal Creek and its continued operation. That's really going to keep the market down in the tube as far as material availability. And it's typically a base load plant, which means it operates at a higher capacity. It's maximum output. So that produces the best ash that you can. And it sits right on its mine. So all the planets line up there to produce really high quality fly ash.
Perfect. All right. Any questions from the audience? We do have one in the back here. Okay.
What changes for design water cement when you're using these different options?
I'll start. For a PLC mixture, you won't change your water cementitious materials ratio. It is, it's 1-to-1 in the concept and in the dosage. You would maybe change some admixture dosages, just dependent on Blaine. It's a Blaine difference. It's not a chemistry difference. And then these guys know it's if it's a strength issue, you lower your water cement ratio. But then again, do you really need that strength? It's a durability topic, really.
Yeah, and I would expand on that. Obviously, if you look at design under ACI 301 or 318, there's two things to determine your design water to cement ratio. The first is your strength requirement. Most of the time you're going to meet that. The second is your durability aspect. Particularly here, where we're in North Dakota, right? And most of our exterior work is F3, that's going to dictate. So that, as of today, if you look at the design guides in ACI or ASTM, that remains the same independent of any of the cementitious products that we're talking today. Now, how the designer, the mixed designer gets there may indeed change. They may need to use additional water reducers or whatever, depending upon which product that they use. But as far as a design parameter, it's the same.
Yeah, and as far as fly ash goes, it's typically one of the biggest physical attributes of the fresh properties is the reduction of water need because of all the spherical nature of the particles.
And just to clarify, the codes all already say water cementitious materials ratio. So these provisions in the code for F3 environment are water cementitious materials. So the number doesn't change.
Okay, any other questions out in the audience? TJ, I'll go back to you. You know, we're talking about different materials that have been put into the spec here in North Dakota. Can you talk to us a little bit about the process of how you evaluate the materials once it comes into materials and research, the testing that you do, and maybe just give a time frame on how long you know, a material takes to go through that process before you stamp it and say, yeah, you know, it's going to work here?
I guess that would be kind of a muddy subject depending on the material or what we're talking about. In these, in this context, SCMs are all relatively used by other states, other agencies around us. So we had a level of comfort, you know, reviewing the surrounding data, the industry data, and then we did some localized testing of our aggregates along with some of our mixes, and then we'll monitor that going forward. I don't know if there's like a set plan or guideline for how every product would be handled. I know ETS is involved in that, and we have some avenues for that, or the trip proposals. If there's a need or a, how would I say, a utilization for a product that's not in the spec, we would be open to reviewing it and talking with the proper subject matter experts to get it in the spec if there's a need for it.
Okay. All right, quiet group here. So I could continue to ask.
It's almost social hour. They're all ready.
That is. So with that in mind, we have our next session with the governor at 4 o'clock. So we'll want to make sure that we're back in this room by then. But what I'd like to do is maybe just have each panelist give just a concluding statement and maybe a plug for some of the technical resources. We're all technical people here. We're specifiers. Where can people turn to? Again, Joe, I know you gave your information, but you know, slag cements, PLCs, those type of things. Michelle, kind of give a plug on PCA and Doug, and then we'll conclude our section here.
I don't know if I'm going to cover all of that, but I guess what I would say is materials are changing. There's no need to fear. Most of them, like I said, you're going to be having new products come into this market. Most of them are known entities. There are paths, there are ways. So it's definitely something that's changing. But as I said before, my focus is update to the most recent version of national specifications that are out there. And most of these are known entities. So it's nothing new, but things are changing. I mean, we have to be open to that. So.
Yeah, I will second what Joe said. If a new material comes on the market, the most important thing is, of course, to consider innovation, especially on the sustainability side. But the second thing is to make sure that material has been well vetted. And the best way to know that is if it's accepted by ASTM and ASHTO. That's a minimum bar. That doesn't mean it's the best thing that you can choose. There's so many choices in making concrete. But when it's locally available to you to consider, make sure it's been vetted through a standard. And then secondly, for continued information on PLCs, you can go to PCA's website, cement.org, and that is in the slides that you'll get. But also we have another website specific to PLCs, and that's greenercement.org. And that gives you case studies, including states that have had successful paving projects, and they'll give you information on, you know, their testing, their pre-authorization, their post conducting evaluations of long-term pavements as well. So that's all available on the greenercement.org website on PLCs.
And to echo the other panelists, it is a changing landscape. You're going to see different materials coming at you. You're going to see harvested ash. You may see blends of harvested and run of plant. You may see a natural pozzolan come your way or a ground bottom ash. Evaluate these materials on their merits, and to her point, you can look at the ASTM designation or meeting those specifications as a minimum hurdle for performance. And as far as information, you can go to flyash.com for any information, and you can, I think there's a link in there where you can just send a message to us, and if you have any questions, we'll be more than happy to answer them.
I guess moving forward here, with all the changes in the market, utilize the new materials you have to make long lasting and durable pavements, work with your mix designers and your industry experts, reach out to them to make sure you have all your new components of the mix figured out. So when you get to paving, we get everything we want and have long lasting pavements.
All right, well, thank you to our panelists. Let's give them all a round of applause.